Hi everybody. Today you're going to be taking notes on slope, and this is the paper that you're going to be writing everything on. Make sure you copy everything that I do. The slope of a line is the rate of change between any 2 points on a line. It is a measure of the steepness of a line. Okay, we've been talking about rate. Okay, slope is rate. That's exactly what it is. To find the slope of a line, you just need to find the ratio. The ratio is a comparison of two numbers of the change in y, which is the vertical change, to the change in x. Okay, and I give you a couple examples of what that could look like. You could use slope, you could think of it as change in y over change in x. You could think of it as y minus y over x minus x, rise over run, and the vertical change over the horizontal change. They all mean the same exact thing. And different teachers may call it different things. At different times you'll hear me say rise over run. Sometimes I'll say change in y over change in x, y minus y over x minus x. Okay, so you can use all of those terms interchangeably. Okay? Let's look at the first example that we have to find slope. Okay, so we're going to find the slope of the line that passes through. The first point is 2, 2. Okay, now first I'm going to just graph it. Oops. .2 would be here. Having a little hard time with my pen. There we go. And I'm going to label that 2, 2. And then the other point is at 5, 4. 1, 2, 3, 4, 5. That's 2, 3, 4. Okay. It's a little sloppy on this pad. Okay. So now, if I were to graph that line, those would be my 2 points, and I would create a line. And basically, you're looking for the rise over run. So I could do this a couple of different ways. I could find my change in y over my change in x. So if these are my 2 points, this would be my x, and this would be my y. Okay? And then this would be my x, my 5 would be my x, and my 4 would be my y, right? You know that your ordered pair is x, y. So I can take my 4 and I could subtract my 2, and I could put that over 5 minus 2. Okay? That would be my change in y over my change in x, or my y minus y over my x minus x. 4 minus 2 is 2. 5 minus 2 is 3. So the slope would be 2 to 3. Okay, the ratio of the change in y over the change in x. That's the rate that this line, that's the slope of the line. Okay, another way you could look at it is rise over run. Okay, and you're going to start here at this point, and you're going to count how many times did it rise. 1, 2. Okay, that would be a 2. And the run would be the x. 1, 2, 3. So that would be my rise, and this would be my run. Same thing, 2 over 3. Okay, you could do it either way. Sometimes you don't have to graph the points, you'll just be given the ordered pairs. So in that case, I would just do the math like this, because I don't have to graph it, so there's nothing to count. It's good to know all the ways to do it. Either you do your change in y minus y over x minus x, or you could do the rise over run, depending. Okay, let's take a look at the next example. Okay, I just forgot to mention, this is called a positive slope. If you notice, okay, when you figure it out mathematically, you have a positive number, and if you look at your line, your line is going in a positive direction. I'm just rewriting a bigger line here. Okay, that would be a positive line, and you'll see the different positive slope. You'll see the difference on the next one of a negative slope. We are not going to see many negative slopes at all this year, but you will see more next year, so I just figured I'd give you one as an example. So here is an example of a negative slope. Again, you won't see many of these, but I just wanted to show you. We're going to find the slope of the line that passes through 0, 3, and 6, 1. Okay, I'm just going to rewrite my ordered pairs here. Okay, and I have 6 over 1. So this would be my x, and this would be my y, and this would be my x, and this would be my y. Okay, I'm going to plug in, and I'm going to do y minus y over x minus x. Okay, so I'm going to take my y, and it doesn't matter which y you take first, but then you have to take that same x first. So I'm going to do 3 minus 1 over 0 minus 6. Well, 3 minus 1 is 2, and a 0 minus 6 is a negative 6. Okay, and I am going to simplify that, so I have a negative 1/3. That would be my slope. Okay, notice I have a negative slope. Now watch what happens when I graph that. My first point is 0 and 3, so that's right here. And then I have a positive 6 and a 1. Okay, that's there. And if you notice, when I graph that, and if you see, that's not a very good line for my points. If you are doing this on your paper, a ruler really helps. I'm just having a hard time with my... Okay, you get the gist here. It's not a very good line. But as you could see, this line is going down. That would be a negative slope. When I figure it out mathematically, I have a negative slope. Okay, if you look at my rise over run, my rise actually goes down 1, 2. That would be down 2. And then it goes 1, 2, 3, 4, 5, 6. So that would be written as rise over rise is negative 2, run is 6. And then you could simplify that. And again, we always simplify a ratio. Okay, this would be my rise, and this would be my run. Okay, and what you could do with slope is you could find more points that would go on that line, okay, because really my slope is negative 1, 3, so really I could find another point on this line by going 1, 1, 2, 3, and I could find that another point on this line would be, again, I'm having a hard time graphing that, would be at 3, 2. Okay, so you can use it that way. Some things you might use slope for in real life, if you are creating some sort of ramp, when you're building maybe a skateboard or a bike ramp, you would need to know different slopes to figure out the angle. Maybe you'll have a ramp, you may have a ramp at your house for a handicapped person that may live in your house that needs a ramp, like with a wheelchair. A ski slope, okay? You could figure out like different jumps if you're an expert skier and you're going over, you know, on the double black diamond slopes. You could find different slopes of the mountain that way, and how you're going to land. Those are things you might think about when you're skiing or snowboarding. Okay, let's take a look at the next example. Okay, for number 3, we have 0.35 and 1,4. And I, as you can see, I do this interchangeably. Sometimes I graph the points. So that would be 3, 5. And 1,4, and you really should always label your points. I don't think I did on the last one, but you really should. Okay, that helps to see that which point is which. Okay, and when I'm finding I'm gonna try to get a line through that. That's a little straighter than the last one. Oops, I didn't want that thick one. Let's see if Okay, and my rise on this one, if I were to count that, that would be, my rise would be 1, and my run would be 2. So it should be 1 over 2. And I do like to do that, and both ways. Also, to kind of check my math, make sure I'm graphing properly, that kind of thing. They should match. So when I use my points, I have a 3, 5, and a 1, 4. Okay, this is my x, this is my y. So I'm going to do my change in y, 5 minus 4 over 3 minus 1. 5 minus 4 is 1. 3 minus 1 is 2. Did I get the same answer? I did. So that works. Again, I like to double check my work, finding it by counting on my graph and also by doing the math. Sometimes you don't have to graph it though, so if you don't have to graph it, you might not do it. You might do it anyway, just to check your work. Okay, next problem. Let's see, number 4. We have 2, 4. And negative 1, 5. This is actually going to be, do you see what that's going to look like? That's going to be a negative slope. Okay, when I connect that, this is what it looks like. Okay, and when I do my rise over run, that would be a negative 1, and that would be a positive 3. I don't like that green, you can't really see that. Okay, let's do the math on that. We have 2, 4, negative 1, 5, and I always just write x, y just to remind myself which is which. Okay, I'm going to do my change in y. So I have 4 minus 5 over 2 minus a negative 1. Oh, we have a 2 minus a negative 1. You want to get rid of your double negative there. 2 plus 1, keep change. 4 minus 5 is negative 1. 2 plus 1 is 3. Negative 1 over 3. I got the same answer mathematically as I did by counting. Okay. Let's take a look at number 5. Okay, number 5 is a little different. You're given a graph with a line on it, and you need to find the slope. So again, I would probably do this 2 ways. Okay, this point right here is at 3, 2. Okay, and this point here is at, looks like 7, and that's 6. Okay, and I'm going to count here. I have 1, 2, 3, 4. Should be my rise. And my run, 1, 2, 3, 4. Okay. I should double check that. Okay. So it should be a 4 over 4, which would be a 1 over 1. And we're going to keep it as 1 over 1 because we want to keep our slope as a ratio. You're going to see when you're graphing lines next year and stuff like that, you could write it as 1, although that technically isn't a ratio. In your equation, you're going to see a slope of 1, which would be a 1 over 1, but we're going to just leave it at 1 over 1. Okay, let's find my my slope using y minus y over x minus x, just to make sure. So we have 6 minus 2 and 7 minus 3. Well, 6 minus 2 is 4. 7 minus 3 is 4. So when I simplify that, I get a 1 over 1. So that's correct. Just want to make sure, because on my graph I'm having a hard time seeing it because it's so small. I want to double check with my math. It's a good habit if you have time. Okay, let's try the next one. Okay, we have, this looks like it's at negative 4 and negative 3. And then we have negative 2 and a positive 3. Okay, so it looks like my rise is 1, 2, 3, 4, 5, 6, and my run is 2. And of course I would simplify that. That would simplify to a 3 over 1. Okay, let's just do this mathematically. When I do my change in y over my change in x, I have 3 minus a negative 3 over a negative 2. This negative 2 minus a negative 1. I just messed up, didn't I? Sorry about that. Let's look back at that. I have a 3 minus a negative 3 and a negative 2 minus a negative 4. That's all I messed up on. Okay, so 3 minus a negative 3 would be really 3 plus 3, and a negative 2 minus a negative 4 would be negative 2 plus 4. 3 plus 3 is 6, negative 2 plus 4 is 2, 6 over 2, which simplifies to a 3 over 1. That's the correct slope. Okay, and we have our last example. Okay, here it says to graph the data and then find and interpret the slope. Okay, whenever you have a graph like this, you should label it. Okay, let's call this hours. Let's call it money earned, and your title could be anything you want it to be. It just should make sense. Money earned. Okay, and you should always label your x and your y. So my x is hours. Okay, and your x is always time, and then my y is earnings. Now you should number your graph. I'm going to have a hard time doing that with my pen here. But you can number your graph whatever would make sense with you. Okay, for you, I should say. Okay, so I'm going to try this. Hopefully it'll work. I'm going to count by ones down at the bottom, but I'm not going to number every one. I'm going to number every other, so I have room. 2, 4, skip 1, 6, skip 1, 8, skip 1, that would be 10. Okay, and then the last one would be 12. Okay, and then on my y-axis, I'm going to label that by 5s. This would be 5. That would be 10. This would be 15. I'm going to skip 1. That would be 5, 10, 15. That would be 20. That would be 25. And that would be 30. And then this would be 35. And then this would be 40. And then this would be 45. Okay. So now I'm going to find it says to graph the data. So 0, 0 would be here. And then I have 2 hours, and that was $15, so that would be here. Okay, and you should label that to 15. And then I have at 4 hours, I'm going to make $30. So that would be here. I don't know if you're seeing what this is doing, but it's not easy. And then at 6 hours, I'm going to make $40 to $5. Okay, and that would be my graph. I'm going to draw a line, and Lord knows how this is going to turn out. Okay, and now I'm going to find my slope. Okay, now on this type of problem, I would always use my mathematical y minus y over x minus x, because it gets confusing. Okay, I mean, it's not too bad. My rise here from here to here is 5, 10, that would be 15, and then my run would be 2. Okay, let's just make sure that's mathematically correct. If I did my y, I have 15 minus 30. I should have done that the opposite way so I didn't have to deal with negatives, but that's okay. And then over 2 minus 4. 15 minus 30 is a negative 15, 2 minus 4 is a negative 2. When I simplify that, I get 15 over 2. Okay, and that would be my slope. That's simplified, positive 15 over 2. Okay, when it says to interpret the graph, you're going to explain what 15 over 2 as the slope means. Okay, basically what it means is I'm going to earn $15 for every 2 hours of work. Okay, if you wanted to, you could find the unit rate, but it doesn't ask you to, so you don't have to. And that's all I have for you today. If you have any questions, please just write them at the bottom, and we will go over this in class. Have a great night.
This is the Ryan Show. Ryan Show. Today in the Ryan Show, we are going to divide. Here we go. Number 1 is 36 divided by 6. 6 times what equals 36? 6 times 6 equals 36. So it is solved. Next one we are going to do is now we're going to do fractions. So for fractions, we're going to subtract fractions. We're going to do 5 3/8 minus 2 3/4. So first we need to find a common denominator. So what we're going to have to do is So what we're going to do is 5 3/8. 5 3/8. We're going to keep that and We're going to keep that in 8, denominator 3/8, and then we're going to change to 4 3/4, the denominator to 8, and 4 times what equals 8? 4 times 2 equals 8, so once you do something to the top, you do the bottom. 3 times 2 is 6. So now you subtract those. But wait!
Oh, yeah, you can't do that.
6 is bigger than 3. And you can't subtract 6 from 3. So, since this number is bigger, we need to borrow from the 5 and bring the 5 to fraction land. And 8/8. Then we add 3/8 plus 8/8, which is 8, 9, 10, 11. 11/8 minus 6/8, which you can do. And you get 5/8. But are we done? Nope. We need to remember our whole numbers. So the correct answer is 2 5/8.
I am so proud of you.
Next one. We're going to do 36 3/16
Oh my gosh, that's a big number.
minus 12/4. So, we need to find common denominators. This one we leave the same. Then this, 8 times 2 is 16. So, 4 times 2, whatever you do to the bottom, you do to the top. 4 times 2 is 8. Now, can you subtract this? Nope. So you need to change this to 35 and bring a whole number to fraction land. And 16 over 16. And do 16 plus 3. 16, 17, 18, 19. 19 sixteenths minus 8 sixteenths. And you get, so 8 minus 9 is 1. So 11 sixteenths, or just 11 sixteenths. Now you need to
Go back and look.
borrow from the whole numbers,
You
which
already
were
did that.
I need to subtract by the whole numbers, which are 35 and 12. So 35 minus 12 is 23. So 23 11/16 is our answer. Last
I
one.
am super proud of my son. He sure knows his fractions.
Last one is 56 minus 32. Wait. 3. 32. And 6. So, common
That's gonna be tough.
common denominator, is 32 for this. Well, least common denominator we need to find.
32 is not a common denominator of 6.
Yes, it is. 6 times. Oh, wait, never mind. Oops. I meant to write 36. 6 times 6 is 36. And you did 6 times 6. So 3 times 6 is 18
Make
6.
that a 3 in front of that. Make that put there a 3 there.
Oops, 36.
And change that one to 36.
Oh, yeah. So, now you do 18 minus 3. Wait, you can't do it. So we need to bring a whole number to fraction land.
I love fraction lands.
36, 36. And then 39, 36. Darn it. So just go to a new page.
39, 36.
What was the other one? 32. And what were we at? 39.
39 and 18. 39, 36.
39, 36. Okay. 39, 36.
And 18, 36.
And 18, 36. Now we subtract those. And we get, drum roll, 21. And then we
21.
forgot the whole numbers.
21 over.
Oh yeah, 21. Wait. Yeah, 21. One more firework if that didn't work.
So. I think it's telling you that it's too long. You need to wrap it up.
Well, we have a minute. Psst.